Okay, so I'm Dr. Gary Johnson. I've been a data architect for a long time. I'm going to start presenting to you a number of principles and factors that should be taken into account in your data architecture that probably are not. So today we're going to talk about one thing that makes your databases slow and is very non-optimized. We're going to show you how to optimize them. This is a principle that you can apply to your current databases, whether they be well architected or not. They could be an absolute mess. They could be very well architected, and you'll still find that these principles are in place. What I'm going to do is show you the example first, and I'm going to talk to you about it. So let's go out here to SQL Server. This is SQL Server 2017. You'll see two distinct databases out here, Sandbox Database number 1 and number 2. You will find in both of them 5 tables, table 1, 2, 3, 4, and 5. You'll see out here, let me just expand number 2 as well, so that you can see the same 5 tables. You'll all see both of them have one particular view. This view links table 2 and number 3. We could have linked other tables together. I just chose these two. Links it from field 1 in table 2 over to field 5 in table 3. Just a standard SQL statement. Very common type of statement that you see throughout systems. As it turns out, in this particular database, in each of these 5 tables, there are about 67 million rows. So it's not non-trivial, or it's not trivial, I should say, in having just a few rows of data. There's actually a reasonable size. Each of these two databases is about 200 gigs apiece between the 5 tables, each of which have roughly 67 million rows. And they're not very well indexed. I want to show the benefits of this. Would the benefits of this be relevant in a very well-structured, architected, indexed, etc. database? Absolutely. But the vision of what we see in the demonstration would not be as dramatic. So I want to show that here this way. So what I actually have an index on field 1 in table 2, and I do not have one on field 5. Again, just a typical view or query statement into something. So we're going to run this on database number 1. So let's go out here to in sandbox number 1. I'm just going to pick a number because this particular query, it takes input of a number to match on. So I'm just going to pick one, 487013. And I'll copy that one so I get the exact same number in the other database. And I will say execute that. Oh, I didn't execute the whole statement. I will say execute that. And now it's executing. And this is going to take roughly 1 minute and 20 seconds because I've run this demonstration before. So in that, what you will see as we get to looking at these in the two databases, what I did not show you yet is there is a adjustment made in database number 2. Okay, so now we have a return in database number 1, and that return from this, it started at 2735 and 20, so it took roughly 20 seconds to run. Okay, we did make a slight adjustment in database number 2. Let's see what it runs in first, and then I'll explain the adjustment. So now I'm in database sandbox 02. I'm going to paste this same value out here that I put in the other one. Again, this just happens to be numbers between 1 and 65 million that it can match on. I execute that, when it's back. And the response there, instead of 20 seconds, was 6 milliseconds. So 170 times 20, 340, so it's roughly 6,000 times as fast, or 3,500 times as fast, sorry, 4,000 times as fast. That's a good response out of your database. This is the kind of response you want out of your database. 6 milliseconds for that response is much better than 20 seconds. So How do we do that? There's two factors, and this happens to be an SQL Server example. The same principles apply in DB2, Oracle, etc. But two factors that are they're default values. They're how the system sets it up for you if you don't change them to match what your actual business needs are. So we're changing to match what the actual business needs are. In this particular case, the two factors are one, by default, SQL Server databases are comprised of a primary file space in a primary file group. There's actually two file spaces here because logging file that's created as well too, but that's basically not one that you work with. So I have this one primary file group. That means all my data, all my indexes for the entire database are all thrown into one thing. That's equivalent to throwing everything you own in your garage and then trying to sort through it quickly when you want one item. That's not how we arrange our house. It should not be how we arrange our data. Databases work with the same principles that arrangement and organization work in the real world. So the principle is we should have things in appropriate rooms. So what you'll see in this database, it's a little bit different. One of the two changes I made is, if I go look at the properties here, I have a whole bunch more file groups. Basically, I took the big tables and put them in their own file groups. Now, does this mean that every table goes in its own file group? Absolutely not. But there are probably anywhere from 3 to 10 major file groups that are appropriate to your particular business. Can't tell you what they are yet without looking at what your system is. You'll get information here in a minute about contacting us when you want yours done to a very higher level. But the basic principle is that you are going to arrange stuff in the way that you would arrange it logically for your house. So as a case here, I have a silverware drawer. It contains all my silverware. But even within that, I don't just put forks and knives and spoons just in a big old heap. I put knives in the knife slot. I put forks in the fork bin. I put spoons in the little spoon bin. So they're each in the individual little spots. You can get to them quickly that way. They're arranged because when I want things, I want a number of things that go with that. So if I want place settings, I want all the forks and knives and spoons. So I put them in one drawer. I don't just randomly spread around the living room, the garage, the attic, and expect to get to them as fast. I arrange them as appropriate for my need, which in this case is quick response. So for instance, in this particular case, if I have states belong to countries. So let's just say, as an example, I have 50 states in the United States. I have 50 rows. Now, the other changes of data in my state table that have accommodated that. I've only got 3,000 states worldwide, but the states belong to individual countries. So 50 of them belong to the country of the United States. One of the things, besides putting things in their nice, neat file space, to say, hey, put my people over in one space and all the information relevant to people over there, and put my customers over in another space and all the information relative to customers over there, and maybe put all my orders that really fall between those two out in their own file space and information relevant to the orders out there. So now I have stuff neatly arranged. And by the way, if I'm just looking at customer data, I don't have to keep hopping over organization and purchase data in order to get to my customer data because I'm only looking in one spot. So that saves me time. It makes things more compact. It makes things arranged just like you would arrange stuff in your house. You're not going to take all the books you own and spread them all around your house. You're going to put them on a bookshelf or make a little mini library, pull them all together. So I know where books are. I don't have to go looking through the silverware drawer for books. So we do the same thing with our databases. You'll also see here I made a file group just for some indexes. Indexes, non-clustering indexes, are their purpose is to help us get to records faster. Okay, so let's get to those records faster. But if my index is spread and mixed around with the rest of my data, then I have to hop over the data just to get to my index. So I'm going to separate those indexes out, which will help me find exactly where in the data I need to go quicker than I'm looking through a little spot. It's the exact same thing as having a table of contents in the front of a book. Yes, your pages are neatly arranged, but if I can know which chapter to go to first, then I hop right to that page and then I'm there quicker. So my index, my table of contents, just like in a book that I put right up at the beginning, I'm going to take that index of data, I'm going to separate those out. So all I did here was I took file spaces, and I made them appropriate for the data going in them. Data and indexes have their own file spaces that are relevant to them. Again, not every table and every index gets its own file space. There are appropriate groupings of those. Too much to explain here in this short video. Now, then the other thing that happened is, again, our defaults here are that all tables, the primary key defaults to be clustered. That's something SQL Server does. Other databases do it, a very similar thing. That's not optimal. It's better than having no clustering at all, but it's not optimal. Clustering says, how do I physically want to arrange the data in my database? Well, if I arrange it and say I'm using this primary key as my clustering, what that means is state number one, the number one is hashed out and it says, okay, given the number one, I want to hash out, I want to go to this spot in your database. State number two, the number two hashes to a completely different location and it's stored over there. State number three hashes to still a different location. It's stored in a third spot. So if I want to do 50 database hits to retrieve information on my 50 states that belong to one country, so I display United States on the screen, I have a drop-down list of all the states, I'm going to have 50 page hits to get those 50 rows out of there. And again, I'm speaking generically. So that's maybe 48, maybe 31, depending on how things actually hash out. As opposed to that, I'm going to say, I'm going to cluster I'm going to take the same table number 3. Instead of clustering on my primary key, I'm going to cluster on a different key, which happens to be, I'll equate this to my state ID in a country table. So all my states will be clustered around the country they belong to. So all 50 of the United States are going to try to be stored on the same page in memory. Now, is it going to overrun on one page and be on subsequent pages? Yes. But basically, you're taking 50 database hits, you're reducing it down to 2 or 3. That's a 98, 96% decrease in number of page hits, which means a significant increase in speed. So we're going to use those smartly. That's why when we saw these out here, because I had these clustered around equivalent of the parent index that I most likely come from. In this case, I did in my view. So I clustered that around that particular index, or around that particular natural grouping, i.e. if I have customers, probably their purchases may be clustered around them. So I can at any time look at it. If it's very common business practice to look at a customer and look at all their purchases, cluster their purchases around a customer. If it's more common to cluster them around stores, then cluster them on stores in the day they occurred on. So you can limit things by most recent stuff within given stores. Depending on what your business need is, if I commonly show all the states underneath the country, then cluster states around the country ID, not around the state ID. That'll make them all compacted in one spot. If I commonly cluster parts around a product, say I'm making bill of materials, then cluster the parts around the products that are used to build in. It makes a nice, neat, less database hits to get to that point. So again, that's why this one ended up with 6 milliseconds, the second one, and the first one took 20 seconds to run. And again, sometimes the change is more dramatic, sometimes the change is less dramatic. I could take this same view, make it even bigger database, and it's going to still be roughly 3 to 6 milliseconds with the properly clustered. The bigger I get improperly clustered, the more time it takes. That's a little hint. This was a free one. So let's talk about this hints in general here. Let's go back to my PowerPoint. What you've just seen is we viewed the example. Again, can you get some standard indexes to give you some benefit? Absolutely. Will you get optimal like you will here? Absolutely not. Actually, the two work in unison very well together. Does it work on big databases? Yes, it works. It actually works better in much more complex interactive environments where tons of things are trying to occur because it helps release resources faster. This one's free. For more, just contact us down here. And the solution is we do not want one single file group. We want multiple, logically based on what your business needs. We don't want to cluster around the primary keys. We do want to cluster around the patterns and usage that you have. So again, if I typically look at, if I show a country, then show all the states, let's cluster the states around the country. Those type of business decisions can help determine how you want to lay yours out. Again, give us a call, contact us. We'll help you do the same thing. Do you like multiple second response or millisecond response? Easy question. And these were not trivial. 67 million roughly 200 gigabytes of data on a laptop. You just saw this run on a laptop. Now, granted, it's a quad core, 64 gigs of RAM, so it does emulate fairly well a low-end server. But it's a laptop that you just saw this run on and get 6 millisecond response time out of a 200 gig database. That's what you can do with your systems if you start applying these principles. Again, this is only principle number 1. There's a couple hundred more. Contact us. Let us know. And avoid bigger servers. You don't need bigger servers. You don't need to write complicated and corner case code that does all sorts of funky things. Normal standard things. The view you saw was quite normal, quite standard, and it ran in 6 milliseconds on this laptop. You don't need to split things up and make multiple instances of your databases because you can't get quick response. Now you can. And you don't need to go say, hey, I got SQL Server, it's running slow. I must need a new database. I must need to go with a big data solution. I must need to go with some other database platform. No. Whatever you have right now is probably adequate. But if you have a Ford pickup and you're not driving it well, buying a Chevy pickup is still not going to make you a good driver. We're going to teach you how to drive that Ford better. You're in the Ford right now. Take it, whether it be DB2, Oracle, SQL Server, you can make these principles apply. This is an innocuous change. Try this one out. If you like what you see out of this type of change, give us a call. We can show you more. Some of them you have to actually change code for. Some of them you have to change structure for. But we can show you literally a couple hundred more optimization features for your data architecture. We will give you a solid, strong data architecture. Give me a call.